Hello, Honors E-Block Analysis class. I am Matthew Pratt,
And I am Jamie Rowe.
and today we are coming to you straight from Death Row Studios to talk to you about a wonderful thing called vectors. In the last video, we discussed how vectors have both a magnitude and a direction. And today, we will be talking about the addition, subtraction, and multiplication of vectors.
All right, so there's two ways you can add two vectors together. You can do it graphically or algebraically. Obviously, it's gonna depend on what information you have. If you're gonna do it algebraically, there's a technique that we can show you here. So say you have a coordinate plane. This is in two dimensions to start. And say you have vector AB coming off of the origin at any angle. Doesn't really matter. And then you have vector AC also coming off of the origin. Of course, it doesn't matter the angle here either. So if you have these two vectors, AB and AC, and you want to add them together graphically, there's a technique you can use where if you take the tail end of AC and translate it across vector AB until it reaches the head of AB, and you draw a vector AC with the same magnitude and direction so that it's almost parallel. It is parallel, actually, to the original AC vector. And you do the same thing with vector AB. So you take the tail end of vector AB and you translate it down vector AC till it reaches the head, and you draw vector AB again across here, parallel to the old AB. So it still has the same, both these new vectors have the same magnitude and the same direction. Now, if you want to find the new vector when both of them are added together, say vector AD, you're going to draw a line from the corner that is made by vector, the original AB and AC vectors, to the corners of the new AC and AB vectors, and that creates the new vector, AD. Now, if you want to do it algebraically, of course, you need to know the two components of vectors AB and AC. So say vector AB has components 3, 2, and vector AC has components 1, -4. All you really have to do to add these two vectors together is add each component. So you would add 3 plus 1, which is 4, and 2 plus -4, which is -2. So the new vector would have a components of 4, -2.
And now, subtraction.
So when you subtract two vectors, it's going to look a lot like the addition of two vectors, except there's going to be one variation. So we have the two-dimensional coordinate plane like before. We're going to draw in vectors AB and vector AC. Now, since we're subtracting, we're going to want to take the opposite of vector AC. So basically, we're just going to reflect it over a line y equals x, and that's shown by the line just drawn in. So that's our new line vector AC. Now it's just like the technique for addition. We're going to want to translate AC across AB until it reaches the head, and draw in the new line segment vector AC, and do the same thing for AB. Translate it up and finish the parallelogram. And now all you have to do, just like addition, is the tail end of the new vector is going to start at the corner between the original AC and the original AB, and it's going to end at the corner of the new AC and the new AB. And so that's noted by the purple line. So that's how you subtract two vectors graphically. Now to subtract them algebraically, it's actually quite simple. All you have to do is say vector AB has components 3, 1, and say line segment or vector AC has components 1, -3. Now we're going to want to take the opposite of the components in vector AC. So the new components of vector AC would be -1 and +3. Now we took the opposite of it. As shown in the graph, we reflected over y = x. So that's just the process that has to be done to subtract two vectors. So you have -1 and +3, and now you add vector AB to that. So that should give you, for the new vector AD, a final answer of with components of 2, 4, which, if you look at the graph, makes sense graphically. Now, that's subtraction. The last thing we're going to talk about is scalar multiplication. If you noticed in that subtraction, when we just took the opposite of the components of AC, we basically multiplied both components of AC by -1. And that's basically what scalar multiplication is. So, say you have a vector AB again, with components, say 6, -2. Now, if you wanted to scale that by a number of 4, you would put a 4 in front of the components, and the final vector would have a new components of 24 and -8. Now, this obviously changes the magnitude, but keep in mind it's still in the same direction, so it's basically the same vector just extended out. So it's going to have the same ratio of components. And that's all for this video on vectors. Look ahead for the next video for a preview of what we will lecture you guys on during class when we come back.